Okay, so question number 43, the entropy of the surrounding goes down when water vapor condenses. So this is a closed system, right? So you have H2O here in the liquid state and H2O here in the vapor state, gas. Okay, so there can be normally a equilibrium here. So the entropy of the surrounding goes down when the water vapor condenses in a closed system. Now think about this. This is a closed system. So in the environment here, okay, there are two things mainly happening. In the closed system, when water condenses, the number of molecules in the vapor phase decreases. Okay. For an example, initially, if it has like 100 molecules, when it condenses, let's say it drops back to 90. Okay. Now think about this random nature of these 90 molecules. The randomness increased or decreased? What do you think? You can quickly use the chat box to answer my question. What do you think about the random nature? When water condenses, so the number of molecules from 100 to 90, what is happening to the randomness of the molecules in the vapor phase now? Is it increased or decreased? What do you tell? So I have one answer saying decreases. What about others? Okay, I have another answer telling decreases. So think about this factor. So when you have 100 water molecules, there is more steric hindrance, like the steric nature around the molecules, right? So the molecules are not much free to move when you have a lot of molecules. But when it condenses, okay, think about this, when it condenses, okay, still you have same volume in the vapor phase, but now these less number of molecules will have higher space to move freely. Okay, so the randomness of these molecules increases, not decrease. It increases because here 100 molecules, they had a lot of space to go. But when you have 90 molecules with 10 molecules being condensed with the same vapor volume, remember the randomness of these molecules are now very high. That is one process that is happening. The other process is when this condensation happens, it's like the formation of the bonds that is going to happen because these gas molecules are now forming some interaction to form the liquid state. So this is typically like the formation of bondings. So which is going to be an exothermic process, which is going to release some amount of heat into the surrounding, where here now using this heat energy, the molecular speed and everything will be higher, which means the motion of these particles will be higher and higher. Okay, so what is happening to the randomness? Randomness is not decreased, it is increased because same volume, less number of particles. So these particles have higher space to move as it wants. Okay, so based on that, this randomness increases. And The second point is the thermal motion also increases because it is like the bond formation when water condenses. So some amount of heat energy is given out, which will increase the thermal motion of the particles. Okay. So the entropy of the surrounding goes down when water vapor condenses in a closed system. This is not true because the entropy of the surrounding increases basically. Why? Because of the increased in randomness. Okay. Heat given out by a system increases the thermal motion of particles in the surrounding. This is one of the conditions that is also happening here. So this is true. The answer is 4. But I want to elaborate some more about this entropy concept just to be sure. Okay. Very straightforward and very simple. Okay. Entropy is the amount of randomness, disorderness, and all those things. That is why when you go from solid to liquid, liquid to gas, the randomness increases so that entropy is increased. Okay. This is okay at your level, and that is totally fine to remember only this. But think about in another way also. Okay. Let's say there is a particle or there is a person who's sitting on a chair and he sees one door that he can go out. Okay. And he sees 2 doors at the second point. He sees 3 doors and he sees 4 doors. So consider about these 4 conditions. Okay. So this person, when he has 1 door to pass, there is only 1 option to go. Okay. And when this person had 2 doors, he has 2 options. Either he can use 1 or 2. And when he sees 3 doors, he can use how many options? 3 options. He has 3 options actually. And when you have 4, he can use 4. Okay. Now think about another person coming in with same condition. Okay. So now what are the possible conditions for passing the door? These 2 person, if you have 1 door, same door, you have to use both of them. 2 door, one can use this one, 1 door, the other one, or he can change. When you have 3 doors, either one person can use 1, the other person can use 2. Then one person can use 1, the other person can use 3. One person can use 3, the other person can use 2. So you can see the combinations increase when you have higher number of doors with higher number of persons. Okay. So this is what normally happens with entropy. Although we say entropy is the amount of disorderness, amount of randomness, this is how this randomness increase. Okay. Normally we explain, we have a nice deck of cards, and when we shuffle, the disorderness increases, the randomness increases, the entropy increases. This is normally what we explain when you are considering about the entropy. So here, how this entropy is increased, because what is actually happening here is when you have higher randomness, means they have several possible places that they can occupy, because 9 or 10 molecules are condensed. So they have these free spaces that they can occupy. That is why this is like free doors that they can pass. That is why this entropy increases, because you have 90 particles that can have different options to be present in the system. Okay. So try to understand that one.